All right, so moving into the next part of this unit, again, still dealing with right triangles. So this is lesson lesson 3. We're going to look at some right triangle trig ratios. So kind of an intro to trigonometry, which a lot of you will be taking later on in high school. Okay. So throughout this unit, you're going to see theta, which is a Greek letter, and this will be used as an angle measure to describe what we call an angle of interest. So there's 3 trig functions, and you want to make sure that you have a calculator that has sine, cosine, and tangent included on them, because you'll use that quite a bit in this unit. The first trig function is the sine function. So the sine of theta, let me not abbreviate that, sine of theta is equal to its opposite side over the hypotenuse. Okay, so if we look at this right triangle over here, it's fairly clear what the hypotenuse is. We also know that it is 5 because this is a triplet, but if you don't know your triplets, then you could do 4 squared plus 3 squared equals c squared, and solve that out. Okay. But depending on what your angle of interest is, the sign of that ratio opposite over hypotenuse will change. So you'll see something like sine of A, so it is abbreviated with the first 3 letters, as all of them are. And that would make A your angle of interest. So if A is your angle of interest, across from that or opposite that is the 3. Okay, so opposite side over the hypotenuse. Your hypotenuse never changes. It's your longest side, so our hypotenuse in this case is 5. Right? If we change that to the cosine, if we change the angle of interest and we look at the sine of C, then that changes your angle of interest to over here. Well, the sine of C, the opposite side of C, is this 4. But then once again, the hypotenuse doesn't change, so that would be 4 over 5. Okay, so this is the opposite to C. The second trig function is cosine. The cosine of theta is equal to the adjacent side I'm going to go back and specify this as a leg, the adjacent leg, the opposite leg, because in terms of your triangle, they are legs. So it's the adjacent leg, once again, over the hypotenuse. Okay, so again, looking at our same 2 angles, we'll go back up here. We're going to do cosine of angle A is equal to, and now we'll see when we look at A, adjacent means next to. So adjacent to angle A is this side right here. next to it, keeping in mind that the hypotenuse never changes, so that has to be the hypotenuse. So the one that's opposite to C is adjacent to A. So your 4. Hypotenuse is 5. That doesn't change. So hypotenuse is adjacent, but it's still your hypotenuse. If we change our angle of interest, so we're talking now cosine of C, then that adjacent side changes. So adjacent to angle C is this side here. So it is the 3. Hypotenuse is still 5. Right? The last trig function is tangent. And the tangent of theta is equal to the opposite leg over the adjacent leg. All right, so using those same sides that we've now have all labeled, the tangent to angle A is its opposite leg, which is across from it, so the 3, over its adjacent leg, which is right next to it, so the 4. All right, going back up here, notice like the cosine of C is the same as the sine of A. Cosine of A is same as the cosine of A. Sine of C is the same as the cosine of A, right? The tangent of A and the tangent of C also have a relationship. So if you look at it, you have tangent of A is 3 over 4. The tangent of C, well, opposite to C is the 4. And then adjacent to C is the 3. So those are reciprocals. All right, and that just has to do with the placement of your angle of interest. All right, so those are your 3 trig functions. You can kind of remember them by just telling yourself, SOHCAHTOA, which is just an acronym for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So SOHCAHTOA. All right. So we can use then those trig ratios to find approximate values for these trig functions. So first of all, if you've only got 2 sides of a triangle, fill in the third. So you could do 12 squared plus c squared equals 13, or b squared equals 13 squared. You will get 5 if you solve that out. This is also a triple that I recognize. All right, and this one's asking for the tangent of angle A. Well, tangent of angle A is opposite over adjacent. Angle A is our angle of interest. Opposite to angle A is 5. Adjacent to angle A is 12. So 5 over 12, which is the exact ratio. Your approximation, you would just go ahead and divide that. So 5 divided by 12 is approximately 0.42. All right, so this symbol means approximate. All right. All right, so looking at cosine of B, same triangle here, so this is a 5. But this is your angle of interest. So cosine, if you look at your SOHCAHTOA, um, then the adjacent is the 5. That is adjacent leg over hypotenuse. So adjacent is 5, hypotenuse is still 13, which is approximately 0.38. All right, and then last one, sine of B. We still have B as your angle of interest. Sine is opposite over hypotenuse. So opposite to B is the 12th. Hypotenuse is 13. So 12 over 13, which is approximate. Right, so approximately 0.92. All right, so the next part you need your calculators for. So again, you need a calculator that has sine, cosine, or tangent. And you want to make sure that it's in the right mode. And hold on, I'm going to see if I can pull up a screenshot here. Okay, so if you have a graphing calculator, you want to go to this mode button right here. So ignore the fact that this image has math circled. Go to mode, and then you want to scroll down and it'll say radian degree. You want to make sure that degree is highlighted. So if degree is not highlighted, then all of your stuff for this unit, any calculations you do with the trig functions, will end up in the wrong mode. And you may not notice. Um, like sometimes you'll get a negative answer for that, and that'll be a red flag, but other times it's just a number, and you might think it's right, and you keep going. So anyway, so make sure that is set, and check it periodically to make sure it hasn't changed. But it should, once you set it, it should be fine. Okay, so back to this. You are really just doing calculator work. So when it says cosine of 48 degrees, you are just typing that into your calculator and approximating it. So we're going to nearest hundredth. Most college professors will actually have you go out at least 4 decimal places, just for the most accuracy that you can get. So if I type cosine 48 into my calculator, then I get approximately 0.6. It says 669, so that rounds up to 0.67. So make sure you round correctly. Go ahead and try these two on your own, because it is just practicing typing those into the calculator. Okay. The other thing that we can do with these trig functions is set up proportions and ratios to solve for missing sides. And we'll talk a little bit about later how to find missing angles in a triangle the same way. So I know we have Pythagorean theorem to find missing sides, but you have to have 2 sides in order to solve it with that. With a trig identity, you need 1 angle measure and 1 side. So if you have 2 sides, you can use Pythagorean theorem. If you have 1 angle and 1 side, you can use a trig identity. So just a reminder of what those are. We have SOHCAHTOA, so sine, cosine, tangent, and then what they are. So identify your angle of interest. It's typically the one that has the number in it. You could really easily find this angle here and switch your angle of interest if there's a different trig ratio that you want to try to use. All right, but I'm going to stick with this one. And then label the sides, so opposite, adjacent, hypotenuse, in relationship to that angle of interest. So 32 is the hypotenuse. There's no changing that. All right. X is your adjacent side. It's next to it. All right, so we have adjacent and we have hypotenuse. In relationship to sine, cosine, tangent, adjacent hypotenuse is cosine. So we're going to say, okay, the cosine of our angle, the cosine of 24, is equal to adjacent over hypotenuse, so x over 32. Our goal here is to solve for x, so we're going to multiply both sides by 32. So we end up with 32 cosine 24 equals x. And once you get to this step, you can just type that into your calculator exactly how it is. And this says round to the nearest foot. So x is equal to, or approximately, excuse me. Okay, so I got 29.23, which rounds to 29 feet. Okay. The next one's a little bit different. So let's go ahead and set that one up. We have here a 20-degree angle, right? That's our angle of interest. And we have the side where 5 feet is would be the opposite side to that. And then where x is located is your adjacent side. So the trig identity that uses opposite and adjacent is your tangent. Right? So the tangent of 20 is equal to opposite, which is 5, over adjacent, which is x. So remembering your goal is to get this x by itself eventually, we first need to get it out of the bottom of our fraction. So you can think of this as a ratio where we are cross multiplying. You could have done the same up here. All right, so the x comes over, so does the 1, and we end up with x times the tangent of 20 is equal to 5. Right? Well, we still need that x by itself. Tangent 20 is glued together. They will never separate. You always have to have an angle measure with your trig function. So to get rid of multiply, we divide. So we're going to divide both sides by the tangent of 20 so that these cancel out. So then you get x is approximately, and you're just going to type that into your calculator, again, just how it is, making sure once more that your calculator is in degree mode if you need to double check that. If you have a regular scientific calculator, it should just default to degree. That's what that little DEG on your display screen stands for. So this is approximately 13.74, which rounds to nearest foot is 14 feet. Okay, so that's it for that one. And I'm going to have you try C on your own. Here's your angle of interest, right? Label your sides in relationship to that. So what is this side? What is this side? Figure out which trig function in SOHCAHTOA you're using, and then solve that out. Okay, have a good night.